exponential function? No, exponential functions is when the variable is in the exponent. So this isn't a true exponential function, but we can still solve it all the same. How would you rewrite b to the 5 halves? Okay, so we have to get rid of the fifth power and the square root, and you can do that in either order. So what do you want to do first?
Square root.
Okay, how do you get rid of the square root? Square root. Okay, so then I have b to the fifth equals, what is 243 squared? It is a really large number.
59,000.
All right, now what do we do?
Oh my gosh.
Mm-hmm.
Okay.
And what are you having us do?
So if we have the fifth root of that, we get positive 9. You guys try B. So, what did you guys do first? What is 81 cubed?
531,441.
And then you do a fourth root. What do you have to put with that? And what's the fourth root of this?
Plus minus 27.
Alright, so those aren't exponentials, but I just wanted to remind you that we do know how to solve those kinds of problems. Are there any issues with that?
So if it's odd, we don't have to do the plus.
Right.
Okay.
Only if you had an even radical. Okay, the second thing I want to talk about is exponential inequalities. With these inequalities, it is similar to the exponential equations in that we want to get a common base. So if I said we had something like h to the negative x plus 14, I want to know when that is less than or equal to 16 to the x power. Okay, for a minute we can pretend like there is just an equal to here. So it's like a problem from yesterday. What do we do?
Common base.
Okay, what's my common base?
2.
So 8 would be 2 to the 16 would be 2 to the. So if we multiply, we get negative 3x. Plus
42.
42 and 2 to the 4x. Okay, here's where it's just a little bit tricky. As long as your base is a number bigger than 1, then we can just do it like yesterday. So drop the exponents and you can actually keep that inequality. But the key for this step right here to work, the base must be greater than 1. Okay, otherwise it doesn't work out this way. So then if I wanted to solve this, I could add over my 3x. So that's the same thing as 7x greater than or equal to 42 divides x greater than or equal to 6. So how would we write that?
6.
Is there a way we could check that and make sure we had our inequality right? Yeah, we could plug it in. So if you put in a 6, you get 8 to the negative 6 plus 14. It's a really big number. 16 to the 6 is the same really big number. So 6 makes them equal. If you want to really see if we have it right for the inequality, put in something greater than 6. So if I put in a 7, then I'm just verifying that this inequality does hold, and that's true. This one is smaller than that one. So you can use your calculator to double check. If you're looking at the book, or, well, the Math Excel book, if you pull that up, they have you using graphs, which I think is a little more complicated than it needs to be. But the key, this only works if your base is bigger than 1. So, if instead I gave you,
I have a question. So, our original statement's true. A less than. What happens if the original statement's like false?
like this
Yeah.
is false. Like if I'm checking an answer and I get that the original statement
No,
is
I'm
false.
saying like just false in general, like, if it was,
1/27 2x plus 1 is greater than 1/9 to the 2x minus 3. Okay. We have to get a common base here. What do you want to use?
3.
Okay, good. Could we use a base of 1/3? Yes.
Yes, you could.
But for the inequality thing, if I just want to be able to drop my bases and do my exponents, I need the base to be bigger than 1 for the inequality to work. Otherwise, if the base is less than 1, it flips the inequality. So on these inequalities, just always make your base bigger than 1. So I'm going to use 3. So 1/27 is 3 to the negative third. 1/9 would be 3 to the 3 to the negative 3x minus 3 is greater than 3 to the negative 4x plus 6. Because my base is bigger than 1, we can just drop it and keep the inequality as it's written. So we would have negative 3x minus 3 is greater than negative 4x plus 6. We add the 4x. Add 3. And the x is greater than 9.
Yep.
How would I write that?
9, 2.
Are these two okay?
First one did.
Okay, I want you guys to try it. No.
I didn't say no, that was your accent.
That sounds a lot like I'm good.
Let's do. Alright, you guys try these. Which one? What did you do for your common base?
3.
So 3 to the 2x is less than 3 to the.
4.
So 2x is less than 4, so x is less than 2. So your answer is? Alright, B. What did you use for the common base?
I used
2,
Okay. So 1/2 is 2 to the
negative
1/16 is 2 to the.
1, negative 4.
So we have 2 to the negative 2x. It's less than 2 to the negative 4x minus 12. So since the base is bigger than 1, you can just drop it, keep the inequality as is. Add your 4x over. Divide by 2, so x is less than negative 6. Do we need any more practice with these?
Yeah.
There's a Math Excel assignment you guys can work on. It's a combination of the equations and inequalities.